Assalamu alaikum. Welcome to another session of data structures and algorithms. My name is Dr. Bilal Wajid, and today we're going to talk about the function add belonging to the linked lists. Now, we have previously introduced linked lists. In the previous lecture, in lecture 24, we talked about create, and then lecture 25 about traverse, and this lecture points and talks about the function add. Now, how do we program a single component of the linked list? You do it using structures. I've already talked about this before. This is a small revision component. So a structure allows you to have multiple variables. So you can have this value as a variable in there, which can store any value as you please. And then you have a pointer by the name of next pointing to the next element. So how do you combine multiple elements? So this is an element pointer A. And then A has been assigned as new element. So this allows A to point to a memory location equal to the size needed for one element. And then A's value, the value that A points to, has been assigned as 90. And the next that A points to has been assigned to null. The same goes with B. You can connect this fairly easily simply by saying that A's next has been assigned as B. So now next is pointing to this location, which is B is pointing to as well. And then B is pointing to null. So this is a simple, linked list having just two elements in there. Now, as always, we need two very important global definitions. One is the length, because we're talking about the add function. Whenever we add something, the length has to be incremented. And the start. Now, the start will always point to the first element of the linked list, right? So making these two global really makes our life easier. Why? Because you can make all your functions the return type void, and you don't have to pass in the first element and the pointer to the function. I mean, it makes your life fairly easier, right? We can add complexities later for double linked list and circular linked list. But right now we just have to understand how things go. So this is our add function. While making the add function, you have two things to consider. The first is, what should you do when the list is empty? And what should you do when the list is filled? Well, to start off, again, we've made the function void, so you don't really need to return anything. And because our element has only one value and a next pointer, so we're just needing one value, that's x, which we're going to initialize to our new element. So how do we resolve? Well, if the list is empty, you can check that by two things. Number one is if the length is equal to 0. The length is a global variable, hence I've shown it to be red. Or you could have also said if start is equal to null, right? So you can check it by both ways. One I've actually written explicitly, the other I've drawn. In both cases, well, the list is empty and you don't need to do anything. You can just print, the list is empty. You can tell the user maybe you should try the, calling out the create function, and you can just end it. Now, what happens if the list is already filled? This is going to be part of our else block here, right? So to begin with, what you need is a pointer A that can point to an element. So that makes a pointer. When you say A has been initialized to start, that means both start and A are pointing to the same location within the memory that stores our first element, right? So now, because it's a linked list, in our definition, you have to start from the beginning. So you're going to start from here. You really have to traverse through all the elements up until you reach the last element, and this is where you're going to add in the new element. Okay? Remember, so I'll say that again. You have to start from the beginning, traverse through all the elements up until you reach the end, and this is where you're going to place the new element. So it is because of this reason we have discussed traverse function in the previous lecture, because a portion of add is actually traversing till the end, and now we are talking about the add function. Okay, so how we do that? It's actually a fairly simple task. You can use the while loop. So while A's next is not equal to null, you should continue. Okay, because A's next is not null, it's actually another element, right? You update A. So A is next, so hence A comes down. Again, you check, right? If A is next is not equal to null, we see that A is next is not null. There is another element. So what you do, because A is next is pointing to another element, you update A, and hence A has been assigned as A is next. Now you go back and check again, is A is next not equal to null? Well, that's not true anymore, because A is next is equal to null. So this is the point where you stop, because you've reached the end. You've reached the last element of the linked list. Okay, so now what you do, you declare a new pointer. The pointer is now pointing to a memory location, and then that memory location's value has been updated to whatever you wanted it to update, and the next is pointing to null. You want it to point to null because add, as per our definition, always adds an element to the end of the list. Okay, so now the only thing left here is that you want this guy to point to this guy, and then this guy is already pointing to null, right? So the way you do that, and we've already discussed this before, you simply say that A is next initially was null. You just simply say A next is now pointing to B. So what happens is A is next, where there was a pointer here, it'll point to the same location as B is pointing to, right? So now you have added the new element in our linked list. Now because you've added the new element in the linked list, you need to increment the length by 1, because initially there were 3 elements, now they have to be 4. Hence you increase the number of elements. This is the complete definition again, how the add function works. I would strongly recommend you try these codes. So here this is our function that we've made, right? This particular program actually corresponds to lecture 24 and 27. So this is our basic structure and our 2 global variables, length and start. This is our create function we discussed in the previous lecture. The add function is here, and then the traverse function. And then we have the main function, which really calls out, which function you want to call out based on the user. So here if I run lecture 24, it gives you the option create, add, delete, length and traverse. You can say, initially you want to just create something, so you just write 1. What is the value that you want to input? You just, let's say 1. Do you want to continue? Yes. Now, we've already created the linked list. So if I say, I want to create again and I give it a value, it says, sorry, the list is not empty. You should try the add function. So let's try that again. This time I'm calling out the add function and I give it the value 10. And when I press enter, wonderful. So let's just look at the length. What is the length? So the length is 2, right? Because I've already added 1 and now I've added 10. So what if I want to traverse and see if the linked list did actually increase? So yeah, look at here. The first element is 1 and the second element is 10. Let's just continue, add quickly a bunch of other elements. This time I want to add 100, and then I want to add 1,000, and I want to add, let's say, 10,000. Okay, so let's look at our length. The length is actually 5, and let me see if we can traverse, right? So you can see 1, 10, 100, 1,000, 10,000, right? So it is actually working, as according to plan. So again, if you like this video, hit the thumbs up icon, subscribe and hit bell icon for new videos. In the next lecture, we're going to talk about delete and length, which will actually finish our linked list series. And then we can move on to double linked list. Up until next time, thank you very much. Bye-bye.